You're welcome to this lesson, and for our lesson today we shall be looking at expanding binomials. We are going to be looking at how to use the Pascal triangle to expand binomials. So what is the Pascal triangle all about? What is it really all about? Now, when we talk about the Pascal triangle, it is a triangle that gives us the coefficients of the expanded terms. And for example, over here, if I write x plus y power 0 and I want to expand this. Now, we all know that anything raised to 0 will give us 1. So 1 is going to be the coefficient of the expanded form of these binomials. It is binomials because we're having two terms. All right. Okay, so 2 there means bi, so we call it binomials. Now if we consider the next term, which is x plus y power 1, you can see here that this binomial carries power 1, and if we are to expand it, we are going to have 1 and 1 as its coefficients. So from here, if we want to get the next term, that is the coefficient of the next term, x plus y power 2, then all we have to do now, let me show us how to get the coefficients of the next term, x plus y power 2. All we have to do now is to introduce a 0 at this first, before the first number and after the last number here, and then we are going to add. So 0 plus 1 will give us 1, then 1 plus 1 will give us 2, 1 plus 0 will give us 1. So there you have it. We have 1, 2, 1 as the coefficient for this expanded binomials, x plus y power 2. So we are going to be using 1, 2, 1 as the coefficients now, which means that if I want to go also to get the coefficient for x plus y power 3, then all I have to do is to come to the previous coefficient, which is the coefficient for x plus y power 2, and then I'll put a 0 before the first number there and a 0 after the last number, and then I will add. Now in adding, I will have 0 plus 1 to give us 1, 1 plus 2 to give us 3, 2 plus 1 to give us 3, and 1 plus 0 to give us a 1. So this is what the Pascal's triangle is all about. If you observe the way the numbers are arranged, it forms a kind of triangle, and that's why we call it Pascal's what? Triangle. So these numbers are actually the coefficients of the terms, the binomial terms, when they are expanded. So this is what we shall be using to expand binomials. I believe that is very clear. So now if you understood this concept, we are going to be using this to expand, as I did say before. Let's now get into the lesson. Now in the lesson, under expanding binomials, we are going to be treating some examples. The first example is here, and you can see it on the screen. It says use Pascal's triangle to expand and simplify the following. Now here we have x plus y power 3. Not quite long. I showed us how we got the power 3, and for us to expand, the coefficient we shall be using is 1, 3, 3, 1. All right. So over here, I'm going to write the coefficient here, 1, 3, 3, 1. So how do we use this coefficient to expand? Let's go right into the lesson. Now over here, I put my equals to. Now the first thing we are going to do is to take this first number here, which is x, all right, and we are going to raise it to the power 3. So which means for us to expand binomials using the Pascal triangle or any other method for that matter, the very first thing we are going to do is to raise this first term to the given power that is there in the brackets. All right, so which means any first term, any number you see here, the first step you are going to do is to write it under the root sign or under the power that you see here. So in this case, the power is 3, so the x will come under the 3. So and that's what we have here, x power 3. Now this one will be used to multiply this first term. So we can say times 1. All right, so that is the first thing we do. We take this 1, which is the first coefficient, we use it to multiply this x, which is 1 times x, and then this x, which is the first term, we raise it to the given power here. In this case, it is 3. So that's the very first thing we do. All right, now in the next step, we are going to write our plus. All right, then we come again, we've used this first coefficient. Now we come to the second coefficient, which in this case is 3. We take the 3 here, and we say multiplied by what? We come to this x that is here, we'll write it x. Now at this point in this second term, this x cube, when writing it in the second term, the power is going to reduce by 1. So if we subtract 1 from the power, then it's going to give us the second term for x, which is x squared. So we take our 3 to multiply the x, then we go to the first term, take the value we got there and reduce the power by 1, and there you have it, you have 3 times x squared. Now at this point, when you are getting the second term, after you've done this, the next thing you do is to come into the bracket and take the second binomial, this second number that is here, all right, which is y, and then you are going to write it here and put it as y power 1. Now the essence of what you are doing is that the first number that appears here will be reducing, while the second number you see here when it appears in the second term will be increasing. And I'm going to show you as we progress in this lesson. Now I believe you understood how this second term was when we arrive at this second term. So now we move over to the third term, which is the second 3 that you see here. So we write our plus, take the second 3, which is 3. Now we are going to multiply it by, we come to this second term, the x squared that is there, we reduce the power, 2 minus 1, we reduce it by 1, 2 minus 1 is 1, so the x will drop to what? To x power what? 1. Why the y that comes first here, when you are writing it in the next term, is going to increase from 1 to 2. So we have times y power 2. So you can see again that we started with x cube. As we progress in the expansion, this x cube will be dropping. So in the first term it is x cubed, in the second term it is x squared, in the third term it is x power 1. Now there is no value for y in the first term because there it is 0. All right, so but in the second term y becomes power 1 because it started increasing in the second term. Then in the third term it has y power what? Power 2. I believe you're understanding that. Okay, so now let's move over to the last term, which is this last coefficient that is here. So we are going to say plus 1, and then we are going to multiply it by x, and then the x here, the power will change from 1 to 0. Don't forget it is decreasing. Then the y will increase from power 2 to power 3. So we have y power 3. So there you have it. This is how the expanded form will now look like using the Pascal triangle, which is the coefficient you see here, 1, 3, 3, 1. All right, so let's move on to the next step. In the next step now, we are going to simplify everything that we see here to arrive at a particular answer. So x cubed times 1 will give us x cubed, then plus 3 times x squared times y power 1 will give us 3x squared y. That's what it's going to give to us. Then plus, then here we have 3 times x times y squared will give us 3xy squared. Then we have plus, don't forget that x power 0 is 1 from what we did before. All right, I believe you know that. So x power 0 is 1. So 1 times y cubed is going to give us y power 3. All right, so this is going to be the final solution to this problem. Now, one important point I want to point out here is that when we talk about the power being 3, the coefficient has to be 4. So you should know that whenever we are dealing with by using this binomial expansion, Pascal's triangle to expand any given binomials, if the power is 3, then we are going to have 4 coefficients. If the power is 4, we are going to have 5 coefficients. If the power is 5, we are going to have 6 coefficients, and so on and so forth. All right, so I believe you understood this explanation. Now if you do, let's quickly take a second example. In our second example, I'm going to show us a slightly different example than this. Okay, so we are still progressing. We are taking it little by little, starting with the simple examples before we move on to the complicated one. So here we have x minus 2y all power 5. So we have x minus 2y power 5. So how do we expand this? First of all, we need to get the coefficient of power 5. All right, so and if you remember how we started, I showed us how to get the coefficient here, and for x for power 3 we have 1 3 3 1. All right, so for us to get our x plus y power 4, that is for us to get power 4, we have to add 0 to the first number and 0 to the last number, and then 0 plus 1 is 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 0 is 1. So this is going to be the coefficient for power 4. Now if we have x plus y power 5, then we do the same thing for the previous coefficient, and we add 0 plus 1 is 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and then 4 plus 1 is 5, 1 plus 0 is 1. So there you have it for power 5. The coefficient we shall be using is 1, 5, 10, 10, 5, and 1. So we're going to write it up here. So the coefficients are 1, 5, 10, 10, 5, 1. Now once again, you can see that when the coefficient is 5, when the power is 5, well, if we count the number of coefficients, it is going to give us 6. So we have 1, 2, 3, 4, 5, 6. So we have in 6 terms we are going to expand this particular algebraic binomials here. We are going to expand it into 6 terms, and the coefficients are 1, 5, 10, 10, 5, and 1. So let's get right to it. Now, like we did earlier on, we are going to take this 1 and then multiply it by the first term you see here, which in this case is x. Now always this first term must come under whatsoever power we have here. So here we are having power 5, so we are going to write this x to power what? 5. So that is the first term. Now for the second term, we are going to take this same x, we are taking the second coefficient 5 and multiply it by this same x, and then the power for the x in the second term will reduce by 1, so we have x power 4, and then we multiply it by the second number. Now this is where you have to be very careful here, because in the second number we are having a negative sign, which is minus 2y. So for us to expand that, we are going to put our minus 2y into the bracket and raise it to power what? 1. All right, so I believe that step is clear. Then we'll move on to the next one. The next power there is what? 10. We write out the 10, and then in the second term here we're having x power 4. Now to write it in the third term, the power will have to drop by 1. So we say 4 minus 1, and that will give us 3. So x in the third term will become power 3. Then we come over to the next term, which is a minus 2y, which will now increase to minus 2y power 2. Okay, so let's move on, please. Let's come down here to continue. We say plus what? We come to the fourth term, which is coefficient is 10, then multiply. Over here you can see that the power is what? 3. So if we are writing the x in this fourth term, the power will drop by 1, so we have x power 2. Then our minus 2y will increase to what? Minus 2y power 3. Then we say plus. Now we go to take the next coefficient, which is 5, and then multiply it. The x will drop to 1. Then our minus 2y will increase further to what? To 4. Then finally we are going to have plus we take the coefficient 1, then multiply it by x, which is power raised to power 0. Then we have times our minus 2y will now be raised to 5. So there you have it. If you check these numbers, if you check across the terms, you will see that this first number here, x power 5, is decreasing across the terms, while the second number, which is a minus 2y, is increasing across the expansion. And if you check the last value for it, minus 2y here carries the power 5. Okay, so let's now expand this very quickly. Over here, we are going to have now x cubed, x power 5 times 1 will give us x power 5. Now don't forget that in the second term there is a negative sign there, so minus 2y power 1. As long as we are having an odd power here, the negative sign will remain. For that reason, this positive sign will change to negative sign. So plus times minus will give us what? Minus. So we have minus there, and then the 5 will have to multiply the 2 to give us 10. So we have minus 10. Now for the letters, we have x power 4 times y. So we have x power 4, then y. Then we quickly move to the third term. In the third term, you can see that we are having an even power. All right. So which means the negative sign will turn to plus, and plus plus will give us plus. So we'll write the positive sign out, and then 2 squared will give us 4. 4 times 10 will give us what? 40. So we have 40. Then x power 3. Then the y will become y squared. You can see that in this second term, y is power 1, but in the third term, it increases, while the x decreases, okay? And that is how we carry out our binomial expansion, okay? So we move on to the next term. Now, in the next term here, because the power is negative, is odd power, all right? So we are having an odd power. The minus will still remain there, and it will turn the plus to minus. So which means over here, pardon me, we are going to have a negative sign, and then 2 power 3 is 8. 8 times 10 will give us 80. Then our x squared will be there, and our y cube will come in here. Let's see if we can still take one more term over here. So we have, before we write out the term, let's check out the power of the negative number. Here we have minus 2y power 4. Since the power here is even, that means the sign here, which is negative sign, will change to positive sign. So yes, we can go on to write our plus. Then 2 power 4 means 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. And then 16 times 5 is going to give us 80. Then x, then y power 4. Then we move on to the last term. We come here to write it, plus. Now we know that x power 0 is 1. And then since the power is odd, that means that this minus sign will be retained. So once again, I'm going to wipe off this, please pardon me. And then we'll write our negative sign. All right, so 2 power 5 will give us 32. 32 times 1. Then we have our 32y power 5. So there you have it. This is going to be the solution to the problem that we have here. I believe you are understanding this, and if you have any more questions, please, I would like you to leave it in the comment box. I will quickly take one more example, and in that example I'm going to show to us how we can apply the binomial expansion, how we can apply it and use it to simplify terms. For example, look at these terms: 1.1 power 3. Okay, now if we are asked to simplify 1.1 power 3, how are we going to do that? The very first thing we do is to write this 1.1. We are going to split it. We are going to write it as 1 plus 0.1 power 3. So you can see here that we have splitted this 1.1. What we simply did was to remove this whole number. We took out this whole number, and if you are pulling it out, if you are separating this whole number from here, the 0 of the decimal number there will come up, and then we have 1 plus what? 0.1 power 3. Now we already know that the coefficient for power 3 is 1 3, 3, 1. And that is what we are going to use to expand this. So in the next step, we're going to write this out fully. We're going to say 1 plus 0.1 power 3 will become, we take this 1. We know that 1 times anything will give us 1, all right? So I'm just going to write this out for the sake of those of us that are just learning this for the first time. I'm going to show you the process, all right? But in subsequent examples, I'm not going to do that. I'll just go straight forward. Now we take this 1 that is here, which is this 1. Then use it to multiply the first number here, which is 1. Now this first number must come under the power that you see here, which in this case is 3. Then we go to plus, take the next coefficient, which is 3, multiply it by this first number, which is 1. Now this power 3 will drop to power 2 in the second number. Then we can now introduce our 0.1 power 1. Then we move to the third term. The coefficient there is 3, so we say plus 3 times what? 1. Then in this term, the power of this 1 will drop from 2 to 1, and then the 0.1 will increase to power 2. Then we can come over to this place, we say plus, we write out our 1, then times what? The 1, okay, will drop from the power of the 1 here, will drop from 1 to 0, while the power of the 0.1 will increase from 2 to 3. So there again, across the term, the first term is decreasing while the second term is increasing. So finally, we are going to arrive at 1 cube is 1 times 1, we have 1, plus 1 squared is 1 times 3 is 3. 3 times 0.1 will give us 0.3. Then plus 0.2. So here we are having 3 multiply, because 3 times 1 is 3, multiplied by 0.2 is 0. 0.1 squared will give us 0.01. All right. Then finally, we say plus, and then over here we have 0.3, which is 0.001. Pardon me for that. That is to say, our 0.1 power 3, if expanded, it will give us 0.001. Okay. Now the reason why I wrote it out is because 1 power 0 is 1. 1 times 1 is 1. So 1 times anything will give you that particular thing. So if we expand this 0.1 power 3 and we multiply the result by 1, it's going to give us 0.001. So there you have it. Finally, we are going to have 1 plus, here is 0.3. We have to expand this one out, okay, which will give us 0.03. If you multiply 3 by 0.01, it's going to give us 0.03. Then here we have plus 0.001. Now, if we add up this value, we are going to have 1.331 as our final answer. Now, you can go on ahead to use the calculator to multiply this out, and I'm sure you are still going to arrive at this answer. So there you have it. This is how we use Pascal's triangle to expand binomials. So in this lesson, you've been able to learn what Pascal triangle is. Pascal triangle does give us the is a triangle that gives us the arrangement of numbers that forms the coefficient of any algebraic expression when expanded under a given power. So these are all the examples of your Pascal's triangles. For each of the terms here, you see each of the binomials you see here under the respective powers. All these numbers you see represent the coefficient of the expanded terms. So we've been able to use that to expand binomials, and we've considered 3 examples. For the first 2 examples, I showed us how to use the coefficient of Pascal's triangle to evaluate, to expand binomials. And in the last example, I showed us how we can apply that concept of binomial expansion. I can use it to evaluate terms. And I believe you've been able to enjoy this lesson. Please, if you do, I want you to like this video and share it with your friends also, and please don't forget to subscribe. I want to thank as many of you who have subscribed so far. And I also want you to encourage your friends to also view these videos and also subscribe. Thank you very much, and I will see you in my next lesson.